So now in this video, we're going to look at using an NPN bipolar junction transistor as a current source. And so, generally speaking, we will probably have a certain amount of current that we want. Using an NPN bipolar junction transistor, we take that current. I'm going to focus on 10 milliamps at the beginning of this video, and that is the same as 0.01 amps. And so, if you have a voltage in mind, we're going to set the current with 5 volts. We need a 500 ohm resistor to get 10 milliamps of current. So we'll look at that coming up. But in any case, that is the goal. And here is the basic circuit of a current source. The load, if you're using an NPN bipolar junction transistor, the load is on the collector side, right there. Of course, we set the signal at the base. There is a about 0.6 volt drop between the base and the emitter. So if we give the base 5.6 volts, the emitter will see about 5 volts. And then we have the resistor. So this is going to keep the voltage across this resistor the best it can. And the current that will be provided will actually come from collector to emitter, as long as you make this right. So you don't want a lot of current flowing in here. It's better to have a weak voltage source at the base. But in any case, it'll set the voltage. The current will be provided from collector to emitter. The amount of current depends on the resistor. So 5 volts across 500 ohms will give us 10 milliamps of current. And so this is absorbing about 5 volts, and so you'll have to have quite a bit more than 5 volts as a power supply to keep the current flowing through there. That's another thing. But other than that, you'll have a predictable amount of current going through the load even as the load changes. First circuit we're going to look at is the NPN bipolar junction current source, which is set with a Zener diode. And so we're going to lose 0.6 volts, and we want 5 volts, so that works out if we have a 5.6 volt Zener diode, which I do. And so first off, let's look at the transistor. This is the 2N3904 NPN bipolar junction transistor. The emitter is the left pin, base is the middle pin, and collector is the right pin. So if I turn it this way and put the base to that jumper there, the resistor is down one row. It's a 510 ohm resistor. Now we have collector on top, base in the middle, and emitter at the bottom. Here is a 5.6 volt Zener diode, and you can actually see it somewhat. There's the 6, V, and 5. Let's see if we can see it. I think you can see it. There we go. C5V6. So it uses V in place of the decimal point. We want to reverse bias that. So the cathode is towards the positive side, anode towards the negative side. We need to pass some current through it to get that voltage built up though. So we're going to take a 10 kilo ohm resistor. This Zener diode does not need much current. 10,000 ohm resistor. So we'll get that voltage built up there as current passes through it. It's going to pass more current if more voltage is applied to it. So it's going to hold 5.6 volts there. The main takeaway though is now we have about 5 volts across the 510 ohm resistor. When we did the math, we saw that 500 ohm resistor would be nice, but I don't have a 500 ohm resistor in this kit anyways. I have a 510. So this meter we just need to set to milliamps, and you can see milliamp on there. The red probe stays in one spot whether we're measuring voltage or current other than very high current right there. And I have 9 volts at the rail right now. So you can see there we got 10 milliamps of current as we calculated pretty nicely. I'll grab a green LED, doesn't matter what color LED. That was with no load. Now we have an LED, so a lot more load, of course, from LED to nothing. And there you can see we still have 10 milliamps of current. Let's try a red LED and see if it still holds. I only have 9 volts at the rail. There we go. We hit kind of a weak point right there. And so we need more power. So you can see 9 volts at the rail. I'm going to bring this up to 15 volts. So we do have to be careful with how much power we apply, and because each one of these components, based on the voltage across them and the current going through them, will create heat. So I have a 10 kilo ohm resistor protecting that 510 ohm, and I have the LEDs also taking some voltage off of that 510 ohm resistor. So we should be perfectly fine at 15 volts. But the main thing is, now that we have more voltage, we have more available power, we're back to that current load. And let's try 4. I think this will be a little too much. Each one of these is blocking about 3 volts, and then the red LEDs are blocking about 2 volts. So we're blocking about 10 volts total. That might be a little too much. And there you can see it was a little too much there. So now it was kind of hard to see what was going on, but here you can see I have the collector there, the first LED, and then the next LED keeps going. Of course, these have to be forward bias, where the anode is more positive than the cathode, so they light up. They don't pass current reverse bias. If you do raise the voltage enough to pass current, well, reverse bias, it just burns them out. So in any case, got the meter set to voltage right now, and we can first take a look at the rail voltage. Okay, you can't see up there, and there you go, 15 volts. By the time it gets to the rail, though, we got some jumpers and stuff it goes to, we lose a little bit. There's a tiny bit of voltage, but it's pretty much spot on 15 volts. That's why a lot of times I'll set it slightly higher. Now we're going to look at the voltage of the signal right there, and this is why the green LEDs are on. There you can see we're actually about 5.8 volts, but as you can see in this circuit, that worked out well. We have slightly more resistance, and we're probably blocking slightly more voltage base to emitter. But in any case, now you can see without the load on, though, the voltage drops way down. All we're getting is what's going through that resistor, and then there's a diode drop there, but then this resistor, we're getting a voltage divider. So we actually have to have the load going, and we could just have like 1 or 2 LEDs, I guess, in this case, and the voltage should hold about the same right there. And but we need a load going through there. We can look at it without the LEDs also right there. So there's a direct connection to the positive rail. That's 15 volts so across that resistor. I probably shouldn't do that. So let's go across the resistor now, and you'll see we got 5 volts across the resistor because of that Zener voltage. Again, there has to be current going through the load, otherwise it's thrown way off. The Zener diode doesn't have enough voltage across it to build up a voltage, and so the load is needed if you're going to take those measurements. And now we're going to address a problem that you may run into using Zener diodes. So as we saw before, I like the 5.6 volt Zener diode. I also have 5.1 volt Zener diode, and in my Joe Knows Electronics kit, that's all I have is 5.1. I don't have 5.6. So what we can do is we can stack voltage drops. So the reverse bias Zener diode, this particular one, 5.1 volt, and so I'm going to leave this one dot away from where the base is right there. Let's zoom in a little bit. We're going to grab a rectifier diode and fill that gap. So this has to be forward biased right now, so I'll plug it in, and then hopefully we can see that. I just reverse biased it, so there we go. Now it is forward biased. That's very important. The gray stripe is facing this way towards the negative rail right there. That's what we want. So that one, we just want to get its forward drop. Now we're going to need more current than the 5.6 volt Zener diode, and so I'm going to use a 1.5 kilo ohm resistor. So that's going to the positive rail and then to the anode of the diode right there. And that is it. That should give us now, again, probably about 5.7 volts approximately. And so power supply is already on. We can grab, I'll set this to measure milliamps. We can grab a couple LEDs, or first we could do a quick current with no load. So again, this is a lot of voltage for a 510 ohm resistor, but there you can see 10 milliamps of current right there. So we're just going to do it briefly, and I think the transistor though absorbed most of it. So the transistor has probably about twice the wattage rating of the resistor, so we may have been okay. But in any case, there you can see we got 10 milliamps current. We can use different colored LEDs. Remember, green LEDs are just naturally brighter, and looks like the camera's not even detecting it. The red LED looks a lot less bright in person. But in any case, there we had it. And again, we used 12 volts, and we have enough resistance there between those two to limit it that way. But then we had the voltage over there without the LEDs, so we briefly did it without the LEDs at 12 volts. But now, again, we can go higher voltage and be able to have more of a load. Same condition as earlier, so I'm not going to go through that again. And now finally, we're going to quickly go over a couple of variable current variations. So we're going to grab a trimpot here. So 10 kilo ohm trimpot is what I have, and I will face it where the arrow is pointing towards the base right there. You can see we already have the negative rail right there. It's just pins. This slides in really nicely. And so in any case, that top pin right there, or the bottom pin I mean, is going to the negative rail. And I'm going to show a problem with just putting this trimpot voltage divider directly to the positive rail. So I'm only working with 9 volts right now. I reset the power supply, and let's grab an LED. Yeah, because this one we have to see what's going on. So it works actually okay as long as we don't raise the voltage too much. So there you can see the LED. It has some brightness there, and just like we expect, we lower the voltage to the base. There's less voltage across the resistor and less current, but we'll still have that voltage minus 0.6 volts, the same rules. And so we're going to raise this up. Now I'm going to go all the way up, and now we are directly to the positive rail. It's 9 volts, 510 ohm resistor, and it's about as hot as you want it to get. But the main takeaway is the LED is not lit anymore. That's because the current can go through this way so easy that there's no point for it to come through here, especially with the LED. If we remove the LED, it may still pass current, but we want to light an LED. So what we're going to do is yank this jumper. Just take a 1 kilo ohm resistor and put that to the positive rail. So now this is a 10 kilo ohm trimpot with a 1000 ohm resistor in there. But the main thing is we can't just pass so much current through there. That current won't want to go from collector to emitter. And so I'll go all the way up. And you can see LED got brighter because it has more current. And the thing is though, now we can set whatever current we want based on the voltage. We're working with the 9 volt power supply. If we change the voltage of the supply now, that will change the voltage across the trimpot because it is a percentage of the power supply voltage. But in case, you could see the LED got brighter and dimmer, so you know different current was going through there. And it has the same rule. If we put another LED and we have enough power, that it will still hold that current. So we already made that clear. Now what we're going to do is take a light dependent resistor. So there's a resistor schematic with the circle and arrows pointing at it, and that indicates a light dependent resistor. And I'm going to leave that jumper there, but this is going to the negative rail, so that jumper is not doing anything now. And we got the light on there. And from testing, I found 10 kilo ohm actually works alright. So we can change the sensitivity of this with different resistors, and we can change. So right now, when it's bright, the LED is off. Or yeah, if it's bright, then the LED will be off. So I just covered it. I made it dark. That was the problem. So I'll get a flashlight on there. You can see the LED went off completely. I get it dark enough, and the LED is really bright. So that's usually kind of what you would probably run into, because why would you want a light to come on when it's really bright, you know? But in any case, we have that set up there. And so when it is really bright, the light dependent resistor has about 0 ohms of resistance. So you get about a direct connection right there. And luckily, current does not go through the transistor positive that way to negative. There's a diode in there that blocks that. This is the weaker diode though, so you want to make sure you insert it in the right direction. If we raise the voltage enough, then this would start conducting. That would be bad. But if the transistor was in backwards, but since the transistor is in right, we got no problem. So all this is looking at is the other negative rail there, and so we can go all the way to nothing. If you get a bright enough light on the resistor, it's practically nothing. So any current going through that resistor will go directly to ground and would not turn the transistor on at all. Now we get it dark enough, and then you have a high amount of resistance here, and so you can get, if you get it dark enough, this gets to millions of ohms, you can have that complete 9 volts across this area here. And so we'll have, you know, probably about 8.3 volts. I bet that's what we have about now. But in any case, that will set the load about 8.3 volts across the resistor, setting the current for the load. So it won't be the full 9 volts and whatnot. We do have losses, but close enough. So in any case, you can build on these. And if we want to wire this the other way, 10 kilo ohm might not work terribly well, but we'll see the effect. So when it comes to sensitivity, you just adjust the resistor values based on what is working. And again, now that we have the light dependent resistor on the more positive side, so brighter light's going to make it brighter, and unless we get too low. So I did not prepare for this. We need to get it extremely dark, darker than I can get it right now. And so let's grab that. Still have that 1.5 kilo ohm resistor right there. There we go. Now we can finally get it dark enough. We have a low enough value resistor on that side. Remember, I swapped where the light dependent resistor is. So right there, I was able to figure it out just from playing around with these a little bit before. I didn't practice much on this video, but you start getting a feel of what you can do to make modifications as you build different circuits. So just look for a bunch of schematics, and if you're new to building circuits, and look at one slightly different from what you're used to, get a feel for the electrical properties of the components, and later on you'll be able to design circuits just based on what you learn from that. So practice, practice, practice. Anyways, thanks for watching. I will see you in the next video.